Good morning, everybody. We are going to be talking about the scientific method, which I know is review because I know you've been learning about it for many years while in school. So please get out your notes, open to this page, and fill in the missing sections. The scientific method. Essential question: what are the 6 steps of the scientific method? What is the scientific method? The scientific method is a set of steps that helps us ask and answer questions. Why follow the steps when doing an experiment? It makes our experiment more organized, it helps eliminate error, and it helps us analyze our results. Step 1, make an observation. Ask a question. An observation is when you notice something. Why is something happening? And a lot of times we're talking about what's happening in the natural world. So you'll notice something and then you'll ask a question. Step 2, make a hypothesis. A hypothesis is a testable logical explanation of what will happen in the experiment. When making a hypothesis, use prior knowledge to predict the outcome. It's not just a guess. So, for example, if I was holding an apple in my hand and I asked you to make a hypothesis about what would happen if I dropped the apple, you guys have enough background knowledge. Or if I let go of the apple, you have enough background knowledge to know that it would fall to the ground. So it's a testable logical explanation of what will happen in an experiment. When making a hypothesis, use prior knowledge. So that's really important to always pull on because you guys have been alive for a while now and you have a lot of information in your brain that you're going to use to make these hypotheses and predict the outcome of what could happen. Design and conduct an experiment. Plan an experiment where you can test your hypothesis. Make sure you have a way to measure and collect information. It might be measuring size, something to do with time, things like that. So you got to make sure you can record your data somewhere in a table so you can collect data. All experiments must have a way to measure data table, graph, tally marks, things like that. How do I know which type of graph to use? So line graphs show change over time, so that might be the amount of rainfall per month. A bar graph compares data, so we might be collecting data on favorite types of movies for people in the school. Pie graph shows how parts related to a whole, so something that goes up to 100%. So where does all the water on Earth, or where is all the water on Earth stored? Would be could be a pie graph. Step 5, report results. What were the results of the experiment? Explain what happened. Step 6, draw conclusions. Conclusions explain the results of the experiment. Why did it happen that way? So in your exit ticket, step 5 is going to be results and conclusions. So you're not going to have a step 6. You're just going to combine step 5 and step 6. Okay, let's practice. Observation. You notice a plant sitting by the window is leaning over. Hypothesis. The plant needs more water. Experiment. Instead of watering the plant once a week, you change it to twice a week. The plant is now overwatered and turning yellow. So just because it wasn't your hypothesis, just because it didn't perk up and come back to life doesn't mean it was wrong. It means you're just going to keep trying. So let's try again. Didn't work, let's try again. Hypothesis, the plant's leaning over because it's trying to get more sunlight. Experiment, turn the plant around and see if it starts leaning towards the window again. Result, the plant straightens out, then leans back towards the window. So you're just trying to learn as much as you can about what you're observing. So phototropism, if you might have heard of that before, it's when plants move towards light. Sunflowers do it every day. There's some cool time-lapse videos you can watch if you want to Google it real quick. And you'll just see as the sun moves across the sky, the sunflowers follow it. Okay, the scientific method is not set in stone. Chemists will follow the steps a bit differently than geologists who follow the steps differently than biologists. It's more of a guideline and kind of a systematic way to do science that is accepted by the scientific community. Okay, I'm going to link this video actually in the Google Classroom. It's pretty good, or I'll show it before class. Talking real quick about a scientific experiment. And now what I need you to do is to go to your teacher, Miss Pencil, and ask her for the exit ticket for this lesson. You're going to do an exit ticket for a front and back side of the exit ticket about the scientific method and observations and inferences.